Okay, today, this is our newest video. Today we are going to make a pH indicator out of red cabbage, which is actually purple. And we're going to test out its accuracy by using some actual pH test strips and comparing the results. So what we will need for this experiment, so we need a quarter of the red cabbage, which is actually purple. And then we cut it into as many small pieces as we can. You can also blend it if you want to. And then put the red cabbage into a container and fill it with boiling water. Leave it to simmer for 20 minutes and then sieve out the red cabbage. Okay, I've poured in the boiling water and now we're going to let it simmer for about 20 minutes. Later I'll explain to you what we're trying to extract. I already set a timer, so now all we have to do is wait while I go prepare the other materials for testing. 20 minutes, the red cabbage should be done soaking now. I'm going to tell you why we have been soaking the red cabbage. It's to extract this molecule called anthocyanins, which is part of the red cabbage's pigment. The anthocyanins can be used as a pH indicator. The molecules of anthocyanins react with hydrogen ions, and for example, if the solution is acidic, only some of the anthocyanin molecules will turn red. However, as the acidity increases, more molecules will turn red, thus it gives it a deeper reddish hue. The same thing happens for basic solutions. As the alkalinity increases, more react and more turn bluish in color. So it will just turn a deeper and deeper blue, or maybe even purple. These are pH strips of paper, which are actually universal indicators. pH is a measure of how acidic or basic a solution or liquid is. And it actually stands for this thing called potential hydrogen, as the acidity or alkalinity of a solution is determined by how many hydrogen ions are in the solution. So this is actually coated with a chemical similar to anthocyanins to test for how acidic or alkaline a certain solution is. Now it's time to test the pH of the solutions. We have lemon juice, soda water, baking soda. I actually need to stir this. I need to stir this around. And we have some bleach, which is actually pretty dangerous. Yeah. Okay, so now it's just a test of using actual pH paper and later with the anthocyanins to test how acidic or basic it is. So we're just going to see if our anthocyanin solution is accurate. Okay, and we'll go for the lemon. Okay, take it out. Let's see. It's orange, so it looks like a tree. It looks like a tree. It looks like a pH of 3 or 4, between 3 and 4.
Okay, put here maybe.
Put here at lemon. Lemon has a pH of between 3 and 4. I'm gonna test bleach. Whoa, deep purple, deep purple. This one has to be
13 or
careful.
14.
Looks like a 13. This one looks like a 13. And you see the bleach is even bleaching the pigment of the paper, so you have to be very careful with bleach. Okay, now baking soda. I'm gonna do baking soda. Amber, you do the soda water. Take it out. Show me. It's actually it's actually neutral, surprisingly. I thought it would have some carbonic acid or something. Anyway, put it in the soda water area. Now for this part. Oh, green. Green is slightly light. I say it has this has a pH of 9. This has a pH of around 9. So baking soda is 9, bleach has 13, soda water is neutral, and lemon is 4, pH of 4. Use our solution and see if it's actually accurate. So I'm just going to, I think I want to do the bleach first actually. Ooh, it's turning green, slowly green. See? The anthocyanins are reacting, but I think we'll need more for this much. Oh yeah, it's turning darker and darker. I think you'll need a bit more. Actually, quite some more. I think we just have to keep pouring in until it reaches state. It's turning green, which means it is reacting and turning basic. Amber, do you want a syringe? Okay, I think we'll go get a syringe for you. Bleach is too basic, so it's gonna take a while to actually show us. So let's do the lemon juice first. See, it's turning red slowly. So this means that it has So this means that it is actually acidic, but not very strongly acidic because it's still pinkish, it's not actually dark red yet. And you see, it's like the color is actually very similar to what we have on the pH test strip. So anthocyanins, this proves that anthocyanins are a very accurate pH tester, and later we're going to try and play around with them and try and neutralize certain liquids. See, the pink is now stable, so that means that this is the final. Yeah. Now let's try for this. Nothing's happening, so that means it is just neutral. So it's just turning purple. Now for baking soda, which actually should be alkali. Yeah, it's turning green. It's like bleach. I'm gonna mix it around a bit.
Blue.
Like I said just now, it will turn blue when it's alkali. So let's keep going until it reaches a stable color. It's still darkening, so. And but you keep doing that, I'm gonna start on the bleach now. The bleach will slowly get darker and darker, but it's just because it's so concentrated. It's gonna take a while, you see? The color keeps darkening every time we squirt some anthocyanin into it.
I think it's stable.
Okay, try one more time. Try one more time. If it's still stable, then it should.
It's still stable.
Yeah, it's stable. So that is the final color, and it's actually pretty similar to the baking soda as well. Look at the bleach. Look at it has actually bleached the filter paper that much. That's how toxic it is. So kids, don't play around with bleach. It's very, very dangerous. Why did you do that? That could have killed me! Don't squirt hard when you're doing bleach.
What about the other liquid?
I'm gonna do lemon juice again just for fun. See if it can become pinker.
Coco, every time I squirt down, see.
Yeah, I think it'll be faster if you just directly pour the anthocyanins into the bleach. So, oh, it's darkening.
I wish we had used the scissors.
I don't think we have enough anthocyanins to completely turn it, but it's definitely very, very dangerous. And it can also get rid of the natural pigment, as you can see in our pH test strip. So it is very basic. As you can see, it's the darkest of anything else. And even because of its properties, I also think that it might have bleached the color out of it a bit. Because you see, look at the baking soda one. It's completely green. This one we've poured like 15 times more than this, and it's still yellowish. So I think it's also bleaching out it's bleaching the pigments out. Now we're gonna try and play around and start mixing them around. We're gonna play around with the lemon and baking soda solutions to neutralize them. And neutralization is actually reacting with an acid with a base to form salt and water. As you can see, we've tried a few drops and it's actually starting to bubble over and look pretty angry. So now we're just gonna hope it doesn't try and explode. Go, Amber. It actually forms salt and water, and it should turn purple. Yeah, it's starting to turn purplish. Okay, so this is the end result. We've got rid of some of the foam, and by looks of it, because it's so dark, it's still quite alkali. So now we're going to pour in the lemon juice to neutralize it. Yeah, pour it in.
All of it?
Yeah, some bubbles are gonna come out, definitely. Ooh. It seems we don't have enough lemon juice, but as you can see, it's definitely getting lighter, slowly but surely. So this should work really well. If you're trying to do this experiment at home, I really do recommend it. Just be careful with the bleach. It's a really fun way to test out the pH of different household materials. You don't have to use these 4 things. You can use different things. You can even use orange juice, drain cleaner, anything you want to try out with. And mixing them together and trying to neutralize them is pretty fun, as all these bubbles form is very likely carbon dioxide gas trying to escape, but I can't tell for sure. Yeah, it's a really fun experiment to do at home, and it's actually pretty safe. Just make sure you don't try to drink the bleach or something like that.
Bye.